Every time your car turns a corner, something incredible happens underneath you. Two wheels connected to the same axle suddenly need to rotate at different speeds. The outside wheel follows a much longer path than the inside wheel, but they're both still connected to the same axle. So how can they rotate at different speeds? If both wheels were forced to spin together, one tire would have to slide across the pavement every time the car turned. That unwanted sliding wastes energy, wears out your tires, and makes the car less efficient. Engineers needed a better solution. The solution is hidden inside the axle. It's a compact mechanical device called the differential. Although it looks complicated, every component has one simple purpose, allowing both wheels to receive power while rotating at different speeds. Now let's follow the power through the differential and discover exactly how this clever gearbox solves the problem. Power from the engine first reaches the pinion gear. It immediately drives the large ring gear attached to the differential. The large ring gear is firmly bolted to the carrier. As soon as the ring gear rotates, the entire carrier begins turning with it. Inside the carrier are two small bevel gears called spider gears. These tiny gears are the key to the entire differential. The spider gears mesh with two larger side gears. Each side gear is directly connected to one drive wheel through the axle shaft. Now imagine the car moving perfectly straight. Both rear wheels travel exactly the same distance, so both naturally rotate at exactly the same speed. Here's the surprising part. While driving straight, the spider gears don't spin on their own shafts. They simply travel around with the rotating carrier. Everything changes the moment the driver turns the steering wheel. The outside wheel suddenly needs to rotate faster than the inside wheel. As soon as the wheels demand different speeds, the spider gears wake up. They begin rotating on their own shafts while continuing to travel with the carrier. Instead of locking both wheels together, the spider gears roll across the side gears, allowing one axle to speed up while the other slows down automatically. As the spider gears roll, the outside axle is allowed to rotate faster while the inside axle rotates more slowly. Even though the wheels are spinning at different speeds, both sides continue receiving torque from the engine through the same differential assembly. The sharper the turn, the greater the speed difference between the wheels. The differential continuously adjusts without any driver input. Without a differential, both wheels would constantly fight each other during turns. Steering would become heavier, tire wear would increase, and drivetrain stress would rise dramatically. This principle isn't limited to passenger cars. Most trucks, buses, construction machines, and agricultural vehicles rely on differentials for the very same reason. In simple terms, the differential solves one fundamental problem by allowing each drive wheel to rotate at the speed it naturally needs. Now you know the secret. Cars don't turn smoothly because the tires slip. They turn smoothly because the differential intelligently manages the speed difference between the drive wheels. One compact gearbox quietly solves this challenge every single time you drive. Which machine should we open up next? Follow for more hidden engineering.